day from GFG. Let's look at today's problem. Okay, so total decoding messages. A top secret message containing letters from A to Z is being encoded into some form. You are an FBI agent. You have to determine the total number of ways that message can be decoded. The answer can be largely done the answer modulo this. Okay, so let's understand the problem using this example. Okay, so this is our example. So we have given the string 1 2 3. Okay, so this is a string, not a number. So what we have to do is see, I have to encode this string into some format of A B C D dot dot Z. Okay, so I have to decode this actually. I have to decode this string into another string where the elements are only A B C D. Okay, so actually this string is coming from a decoded string. Okay, so after encoding we get that. So after encoding we get this string which is actually given to us. So we have to decode it to get back this original string. Okay, now there may be many original strings whose encoding format is this or encoding answer is this. Okay, so we have to give the number of such answers. If you don't understand, don't worry, this is pretty simple. Let's give some so let's understand with an example. So suppose this is 1 2 3, right? Now if I take this as 1 separate, 2 separate, 3 separate. Okay, now CA, if I encode 1, if I decode 1, it will be A. Okay, if I decode 2, it will be B. If I decode 3 it will be C. Okay, so that's why if I decode 26, it will be Z. Okay, so this is the format given in the question. So now think 1 2 3 are separated. Why I am telling separate, I will come to that later. Think 1 as a unique element, so it will be like A. Think 2 as a unique element, it will be like what? B. Think 3 as a unique element, it will be like C. That's fine. Now there is another answer. Okay, think 1 2 as one element and 3 as another element. So 1 2 actually 4 for D, 5 for E, and 6 for, let's take it from here. So 12 stands for L, right? So if I decode 12, it will be L. Okay, you can do that and check. So then 12 will be decoded as L and 3 will be decoded as C. So in this case our answer is ABC, not our answer. We have to return something else. We have to return the number of decoded strings, that is ABC, LC and something other also. We have to take the give the number of strings. Okay, so but in this case the string we got after decoding is ABC. In this case the string we got after decoding is LC. Now we can do this by like 1 and 1 3 also. So for 13 it is KLM, right? So it will be M. So 13's decoding format is M and 1 is A. So this string will be AM. So for as far our example is concerned, okay, so we have 3 strings which after encoding will give me this string S, both of them, 3 of them. Okay. So what encoding decoding means? Actually encoding decoding means you are actually you are assigning a meaning to an element. Okay, suppose there is an element X, you are assigning a meaning to that element X which is Y. So for 1 I am assigning A. So this is encoding. When you get back the encoded thing, when you get back the thing from which you have encoded A, that is called decoding. So this string actually came after encoding something. Okay, so after encoding something we get 1 2 3. So decoding means we have to get back to this answer. but there can be many answers, not only one. Okay, so these three are the answers of this string. That means if I encode ABC, it will be 1 2 3. If I encode LC, it will be 1 2 3. If I encode AM, it will be 1 AM. Okay, so if I encode these three strings ABC, LC and AM, see, A is 1, B is 2, C is 3. So L is here 12, C is 3. A is 1, M is 20. Also, it will be 23. Okay, so for 23, so 23 is what? I keep the 1 as it is and think 23 as a unique element. So before it will be Y, X, and 23 will be double, right? So it will be AM, AW, sorry, my mistake. It will be W. So that means if I encode AW, I will get 1 2 3. So see, I got 1 2 3 from these three. Okay, so these three are my answers, not my actual answer. The count of these answers is actually my answer as far the question is concerned. So my answer is 3 because I get these three strings which after encoding give me this string. Okay, so this is the question actually. So I want you to understand the question. Let's take another example. Don't think about so this is not a good example. Let's take 1 2 6 1. So I can put it by like 1 2 6 1, or I can put it like 1 2 6 1, or I can put it like 1 2 6 1, or 12. No, there is no another way, I think. 1 2 6 1 1 26 1. Yeah, I cannot do 12 61. Okay, because 61 doesn't represent any character from A to Z. Okay, so the format I am writing is 1 for A, 2 for B, and at last 26 for Z. But after Z there is no letter, right? So if I got any number after separating as a unique element, if I got a number greater than 26, it will be invalid. Okay. So 1261 is not a good option. Okay, so for this case, here I will get A, here I will get B, here C is 3, this is D, E, F. Okay, so F, A. Here will be what? L, I think. F, A. Here will be A, Z, A. So same here, we got A, B, F, A, L, F, A, and A, Z, A. So from after encoding these three strings, after encoding them, encoding means nothing but assign a value to each element. I will get 1 2 6 1. So I have to backtrack the answer to get these three strings. So that is the actually question, and count this number of strings and return. So I have to decode this, decode, and decode. So now let's see how to solve this. So I will tell you solution 1, which will not work because of this TLE, but this is the answer, right? Suppose I have 1 2 3. What I can do is I can extract a, or I can extract 12, but I cannot extract any string of length 3 because that will be, because the value which it represents is actually greater than 26, and I am not working with the numbers greater than 26, so I will not extract any string of length 3. Why I am extracting? Let me show you. So after extracting 1, I will then I can extract 2. Okay, so our rest of the question is 1 2 3. Here our rest of the question is 3. Now I can extract 2 also. So 1 2, rest of the question is 3. Can I extract 2 3? No. Yes, I can extract 2 3. So from 1 to 3 I am extracting, what this means is I am extracting 1 as a separate and 23 as separate. It will represent W, I think, and it will represent A. From this I can separate only 3 and my string question will be null. From here our question is null already. Here I can separate 3, our question is null or empty. So the moment I got an empty, I will get an answer. See, 1 2 3. So just decode 1 2 3, you will get an answer. Just decode 1 and 23, you will get an answer. Just decode 12 and 3, you will get an answer. So decoding is not a matter. Okay, so we don't have to actually decode them. We have to just see the this format, that no of them is greater than 26. Okay, and we have used all the characters here, and that is we have used the full string. So that is the two things. Okay, so no numbers is greater than 26, and we have used all the characters of our string. So see, so all the characters of our string will be used when our question will be empty. So this is the case, this is the case, this is the case. So there is actually 3 cases, so our answer will be 3. We don't need to decode them. Okay, so this is the tricky part in this solution. Another solution is also tricky part, common tricky part, but that is the thing, actually you don't have to decode. Let's take another example. Suppose 1 2 6 1. So we will extract 1, we can extract 1 2, we cannot extract 1 2 6 1. We can extract 26 also. Okay, no, we cannot extract 26. So I'm extracting from the beginning. Okay, either from here, from 1 to 6 1, what I can extract is either 1 or 1 2 or 1 to 6 or 1 to 6 1. Okay, so I can extract only 1 and 1 2. So in every case actually I'm going to extract this and these elements. But if these two makes these two number makes a number greater than 20, I will not take that. Okay. So 1 is my part of the answer, and rest of the question is 261, and in this case rest of the question is 61. Now let's extract 2. I can extract 2, or I can extract 26 also. So in this case our rest of the question is 1. 6 1. In this case only 1. From here I can extract 6. Rest of the question will be 1. Cannot extract 61. 61 is greater than 26. So only this option. Okay. Now here we can extract 1 2 6. Extract 6, right? Rest of the question will be 1. Cannot extract 61. Okay. In this case we can extract 1. So 1 26 1. Question will be empty. So this is our final answer. Here we can extract 1. Question will be empty. This is the final answer. In this case we can extract 1. So question will be empty. This is the final answer. Okay. So this is it. So we have 3 strings. We have 3 strings, right? Which after encoding you will get this 1 2 6 1. We don't need to decode them. Our work is to decode actually, but we don't need to decode them because we just need to give the count of substrings. So after decoding it, that is placing A in place of 1, placing B in place of 2, this will be the decoding part. We don't need to do that. We just have to count the strings, and we got it from this step, right? So we don't need to do that. So we got 3. So this is one solution. Actually this is solution 1. You can apply that. I will give this coding part in the comment section or description, but we will not do that here because this will not work. It will give a TLE. So let's look at the solution which will not give you TLE. Solution 2. But before going to the solution 2, actually solution 2 we will use DP, that is dynamic programming. But to understand dynamic programming, so to understand the solutions process, we need to understand some key points. Okay, so let's understand that. Okay. Suppose I have a number like this. Okay, so there is a condition. Okay, there is a condition given that if your number has a leading 0, okay, or extra zeros, trailing zeros, or 2 or more consecutive zeros, it is an invalid string. What that means? If this is the case, okay, or your case is like this, or your case is like this. This is a leading 0 means 0 in the front of a number, consecutive zeros, 2 or more. Okay, so in these cases it's an invalid string, we will return 0. Okay, so that is the first thing. Okay, so leading zeros is the first thing. 0, 1, 2, 3 not acceptable, or 1, 2, 3, 0, 0 not acceptable, right? The second point is, suppose I have number like this, 3, 0, 4, 5, 6, 1. Now this is a very big number, but we are going to concentrate on only this part. Okay, so we have to decode this, right? So after decoding, we will get some letters from A to Z. So each letter, suppose C, what is the range of it? I mean, what is the range of its encoding element? What I mean to say is, suppose there is 2. So in place of 2, we are gonna place B, right? So what is the range of B? B's range is from 0 to 26. Sorry, 1 to 26, right? Every letter from A to Z, after encoding it, we will get a number from 1 to 26, whatever it will be, right? A number that is not O, any number, any letter, sorry, from A to Z, any letter from A to Z, after decoding it, we will get number from 1 to 26. That means if a number X, which is greater than 26, cannot be encoded, right? So suppose I have number 41. Okay, suppose I have a number 41. Can you decode it? You can decode this by 4 separate, 1 separate, but you cannot decode this by 41 because there is no letter corresponding to 41, right? But you can decode this by like this. That's absolutely okay. Now the case is critical when there is a 0. Okay, this case is critical when there is a 0. Why? Because you have to use all of the characters, right? This is string you have given. You have to use all of the all the characters. So you have to use this 0 also. So you can place either 0. You can place, you can take 0 as separate case, or 30, or 04. Now when you are doing the decoding part, when you are doing the decoding part, suppose from this you extract some number x. If x has some leading 0, if x has some leading 0, suppose x is 0 1, then actually x is not acceptable. You cannot extract s. Okay, you cannot extract s if x has a leading 0. So from here, from this string, I cannot extract 0 4. Now second case is there is no letter corresponding to 0. Is there any letter a to z which actually assigned to 0? Because the range of a to z is from 1 to 26, right? So for 0 we don't have any letter, so 0 will not be applicable also. Now for 30, if you extract 30, 30 will exceed 26, so it is not also acceptable. It is not also acceptable. So that means, so if you have a number, so what I want to say, in this place, whatever there are, the rest part, this is the rest part, this is the rest part. Okay, carefully listen. This is the rest part, this is the rest part. We are not bothering about it. Here is a number x which is greater than 2. So if a number is digit, right? These are all digits. They are forming a number. So this digit, if x is a digit, let's call it, I have given a number with x, so let's call it y. Let's call it a, suppose. Here is a digit, so let's call it d. So if d is greater than 2, then it can be 30, it can be 40, it can be 50, 60, 70, 80, right? Let me write it here. So here are some rest parts. Here is a digit, here is a 0. So if this digit d is greater than 2, then it can be, then this can be 30, 40, 50, 60, 70, 80, 90. 10 0 is not a sensible thing. So 30. So there may be any digit. Then from this string, this is the given string, suppose, and there is a part d0 where d is greater than 2. Then you cannot actually extract, you can extract either 0, you have to extract 0, right? Either you can extract 0 separately, or you can extract 0 together with d, or here is suppose a number x, or you can extract like 0x. Now 0x cannot be allowed because 0x has leading 0, because 0 is in the front. Now 0 as a whole cannot be allowed because 0 does not represent any letter. Now d0 is greater than 26, so it is also not allowed. So actually in this string there is a point where you cannot extract any number. There is a point here from which you actually cannot extract any number. So after you can say after this, so after this here you cannot do anything. So till now you can make some a b c d e f g h, you can make some things, but after that you cannot actually make the rest of the string, because from after this, so from and after this d0 you cannot extract anything, because you cannot extract this part. So so to extract something you have to extract this d0x first, right? So what I mean to say is that you have to extract this part to give a solution. Your solution will contain d0x, all of them, right? So you can extract either, so from here I can extract like 1 2 3 0 4, which is not applicable, you stop here. I can extract like 1 2 3 0 or 1 2 3 0. You cannot do that, 30 is exceeding 26. If you are trying to do this like 1 2 3 0 4, it is also not applicable. So how will you make the string, the decoding string, decoded string, how will you make that? You have to extract, right? So you will extract, then you will decode them, then you will get some A B C F G whatever. So extract is not possible in case you find a digit here D which is greater than 2. So that is the thing actually. Okay, so that is the thing, that is the point what I want to say. So the point is, if I have a 0, there is a character C in my string which is 0, then if the previous character, suppose here is a D, here is a D where C is 0, okay, then there is no answer. So for this case there does not exist any answer. This is the symbol of the does not exist. There also does not exist any answer. Okay, this is the thing where D is greater than 2. The third thing is, suppose this is the case, 2 0 2 4 3. No, let's take this one. Now let's for third point we have to actually solve a problem. Okay, then I can told you. So let's take this string 1 2 3. So you can think 1 2 3 as a number. So I am creating a DP. Okay, I am creating a DP where this is the beginning position. Here is suppose no, so this is a DP. You have given this string S. Okay, this is my DP. Now what I will store here, is up to this, that is 1 2 can be decoded to how many strings? 1 2 can be decoded to how many strings? Decoded to how many strings? Okay, so for suppose this will represent that 1 2 3 can be decoded to how many strings? So that, so the element here will actually be actually our answer for this question. Okay, so this will represent the number of decoded strings that can be possible from 1 to, here number of decoded string possible up to this, that means up to 1 to 3. So up to this number of decoded string possible for 1. Okay, now see that 1 can be decoded by just 1 can be decoded as A, right? There is only one decoded answer, which is A. The answer is always 1 for the first element. Here maybe 2 3 whatever, but the answer will be that, because this is a digit, right? And digit cannot be exceed 10. So for from 0 to 9, 1 to 9, we will get an answer. If it is a 0, I will return 0 at the beginning. So now think this. Here is my A. Okay, here is my A. Now see, here is 2. So from 1 to, I can either extract it by 1 separate, 2 separate, or 1 2 as a together, right? So I can do it by 1 or 2, that is I can put 2 separately with 1, or I can put 2 together with 1. So if I put 2 separate with 1, so that means after 1 I am putting 2. So up to 1 there will be some answer, there will be some strings A, there is a string A, right? A is the decoded string, only possibility is 1. A is the answer. Now if I put 2, it will be AB. Okay, you will not understand the DB process here, actually you will understand here. So I will put AB, right? So this will represent AB. If I put this as together, so I will not see the answer for 1. I will take this as a whole, that is 1 2, and see the before answer before it. So there is nothing actually. So for this case we will do just AB. We will do just 1 2 as a together. So this will represent W, or not W, it will be what, L, I think. L. Okay, so it will be L. So there is 2 answers, right? There are 2 answers. So what are they? They are A, B separate and AB as a whole. Now for 3's representation is C, right? Don't see that. Okay, so forget it. So 3, this answer. Okay, so 3, I can put 3 by just putting separately 3 with A, B and C. I can put the decoding of 3, that is C, separately with A, B, C, right? Or if I take 23 as a whole, I can take 3. Okay, so let me tell you. This is quite difficult to show you for me. So for 3, I can take 3 as alone, or I can take 3 with 23, because I can take only 2-digit number, right? So 3-digit number will be exceeded 26. That's why I can take 2-digit number. So my motive is to take the previous number. So that will give me 23. From 123, I can extract like 1 2 3 or 12 3 or 123, right? So I can keep this 3 alone. I can keep this 3 alone with this 1 and 2. So from 1 is the one answer. From 2, I can keep it like 1 separate, 2 separate, or 1 2 as a separate. Now for 3, okay, if I take 3 as a separate case, it will give me this answer. See carefully, okay? What it will give me is you have to think that I will tell you once more. So I can put 3, just forget about the decoding part, okay? So what we are decoding is actually placing a letter with respect to a digit. So let's forget it for now, because that doesn't work, that doesn't contribute anything to our answer. So think the letter, forget the answers, think about only the digits. So for 1, we have only 1, we have to decode 1 and we'll get answer. For 2, I can place 2 separate with 1, that is 1 separate, 2 separate, or I can place 2 together with 1, that is 12, because 12 is not greater than 26, that is why we are taking 12. So there is 2 answers, right? So for 3, I can put 3 separate with these answers up to 2 there is two answers, 1, 2 or 12. I can put these 3 to these answers separately, that is 1, 2, 3, that is 1, 2, 3 or 12, 3, right? Now also what I can do is I can take this 23 as a whole. I can take this 23 as a whole, and if I take this 23 as a whole, as 23 is not exceeding 26, I can put this 23 after 1. If I take these two as a whole, I will just concatenate my answer, that is 23, to the answer for 1 here. So there are actually 3 answers. Okay, 1, 2, 3. 12, 20, 12, 3 and 1, 23. Okay. So now, suppose here is, suppose here is 2, 1. Suppose let's take more length. That is very hard to explain. So now there is a 2, right? So what I want to say, I can put these 2 separate with the answers for 3. That is, the answers are 1, 2, 3, 12, 3 and 1, 23. I can put these 2 as a separate, 1, 2, 3, 2, 12, 3, 2 or 1, 23, 2. So that will make an answer. Also, if I want to take this 32, I cannot take 32 because it exceeds 26. For this case, it will not work. So I cannot extract 32. If I take this 32 as a whole, I would have checked the answer for here. So suppose this 32 is less than 26, then what we were going is, we just append the 32 with 1, 2 and 12. So then we can get 5 answers actually, but in this case actually we will get only 3 answers. There is 3. Now for 1, if I put 1 with separate to the answers for these 2, then we will get 1, 2, 3, 2, 1, 12, 3, 2, 1, 1, 23, 2, 1. And now I can extract 21 as it's less than 26, less equal to 26, right? So now so what the separate thing means? The separate thing means that I am extracting only 1. Suppose from the whole string I am extracting only 1. That will give me another string by just appending 1 to this answer. Now if I want to extract 21, then I will see this answer. Here the answer, just append 21. So I will get 1, 2, 3, 21, 12, 3, 21 and 1, 23, 21. Right? So there are actually 1, 2, 3, 4, 5, 6 answers, right? So actually 1, 2, 3, 2, 1 will give me 6 answers. So that is the process of the DP. Okay. We are not done yet. We have some more cases. But in a normal case where everything is normal, no 0, no 00, 000 case, everything is normal, this will be the case. Okay. So what we are gonna do for any case, for this case, we are gonna see the answer for it. So we are gonna just append the 3 after the answer of it. So that means actually we are gonna place the number here to here. This 2 means that 3 is separately appended to the answers of 1, 2. That means this part. Okay. And if I take 23 as a whole, that if it is possible to take these 2 characters as a whole, then I will see the answer for here. Now, if I place +1 here, that means we have added the answer for appending 23 as a whole after the answer for 1, which is this. So 3 is our total answer. Okay, so let me do it with some other other example. Then I will do some other then I will tell you some other properties, then it's complete. Okay. uh, let's take also suppose here is 4 6 1 2 2 3. This is the given string, suppose. Okay, so now what we are gonna do is we are gonna do the DP. So for the first element, just place 1. Now 6. So for the first element, the answer is only 4, right? Just forget the decoding part. So actually, if you extract these numbers such a way that every number is less than 26, every number has no leading 0, no consecutive 0, following all the conditions correctly, then you can think this as an answer, right? So the work which is left is just place the letters in place of these elements. Okay, so that's the thing. So that's actually uh, uh, you can say actually nothing, right? So this is the actual work to separate this string by such elements, to separate these strings in such elements where every element is less than 26, every number is less than 26, and does not contain any 0 or leading 0, does not contain any leading 0, sorry, or consecutive 0. Okay, so you can think actually this as an answer. So you can think 4 as an answer. You have to just encode 4, right? So that is actually doesn't mean any work. So for 6 you can, so here we will include the answer for 46. That is 46 can be decoded into how many strings? 46 can be decoded into how many strings? That is, after encoding those strings we will get 46. After encoding those strings we will get 46. So 46, for up to 4 the answer is done, which is 4. Now I can place this 6 separately with 4 or together with 4, right? Now separate with 4 is okay, we'll definitely get an answer, but 46 is less than 26. So in this case we cannot put the 6 together with 4. So we will take this number separately, we will check the answer for it, we will add the answer, and then we will take this as a whole and check the answer before it, which is nothing here. So we will do something, but this number must be less equal to 26, which is not here. That is why we are not adding anything. We are not adding anything. Okay, we are just adding 2. We are just placing 1. Sorry. So the answer will be 4 6. Now for 1, if I, so here what will I place? So up to here we can extract this as 4 6, right? Up to here. Now we have to extract 1. Think that we are extracting some numbers from 461. We can extract as 461 or 4. So this is actually the only way. Okay, so I can put 1 here separately, or I can extract 61 as a whole, but I cannot do that also here because 61 exceeds 26. So this is also not possible. You see, for 461 I can separate it only this way, right? I cannot place 46 1 or 461. These are not possible. Now here you will understand the problem. 2. Okay, so you have to separate 4612 into some strings separated by some elements where every element is less than or equal to 26 and satisfying all the conditions. Oh. Right? This is the answer for 4612, that is here. So up to 461, up to here, there is the answer 461. Now I can put this to separate with this, or that is I can extract it like 4612, or I can extract this 12 as a whole. Then the answer will be, if I extract this 12 as a whole, our answer will be just appending the 12 after this. Okay, so if I took this as a whole, our answer will be this, which is 4 6 12, and if I just put separately, our answer will be 4 6 1 2. So we get two answers, right? So we have to extract strings. Now I can extract the strings like, now think for 2 can be placed separately with the answers of 461, or 2 can be placed together with 1 and append and after the answers of 46. So 46 was like this, and just append 12 to it. This will be another answer. So these two are the answers. That is why I am doing this. What is the process of DP here? The process of DP here is you have to get answer for this element, for this position. You have to get answer for this place. So we will check the answer for here. That we will place here. That is 2. After that, take this as a whole. If this number is less equal to 26, check the answer for here and add it to here. This will be the answer for it. That is the logic why it is working. Because 2 is separate, is appending to the answers of this 4612. 2 is appending with the answers of 4612. 2 is appending with the answers of 4612. Right? As a separate case. Or 22, this 22 is appending with the answers of 461. Okay, so 22 is a separate case, and here 2 is the only separate case. So if you from 4612, there are many cases. So there are some cases where 2 is a separate case, and there are the cases where 12 is a separate 46122, and 22 is a separate case. That is 22 here, suppose here 22. So that is the thing. So after separating, either 2 will be a separate case, or 2 will be this before 2. That is 22 will be a separate case. So if you extract 46122, the possible in every way, you can extract 46122 in the all possible ways. Okay. So what I want to say is, in every case, either these 2 will be a separate case, that is like this, or these 2 will be together with this before 2, that is like this. 22 will be a separate case. 22 will be separated, extracted separately. Either 22 will be extracted separately, or these 2 alone will be separated, extract separately. So if I extract 2 separately, it will append with the answers of these 2. It is 46122, 46122. Okay, so this will tell me where the number of cases where 2 is a separate case. And if I take 22 as a whole, this will give me my answer. That is 46122. That is the only case. So we got 3 answers, right? So if you do, here we get 2, and here we get 1. Now for this case, I can take 3 as a separate case. So that means, what that means actually, four, six, one, two, two, three. There are many possible cases. In every case, either 3 is a separate case or 23 is a separate case. That is 23 separated, okay, or 3 is a separated. So if 3 is separated, the answer will be just appending 3 to the answers of this, right? That is 4, 6, 1, 2, 2, 3, 4, 6, 1, 22, 3, and 4, 6, 12, 3, 12, 2, 3, right? So these are just appending 3 with the answers of this up to this. And if you take 23 as a whole, 23 will have appended to the answers of this. So it will be like 4, 6, 1, 2, 23, 4, 6, 12, 23. So you get 1, 2, 3, 4, 5. 5 answers here. Okay. Here is 3. So that is the method of this DP, process of DP. So how we are getting the answers, this is the process. So this is actually the third point. Okay. That is actually the third point. So DP I will be DP I minus 1 plus DP I minus 2 if the character at I and I minus 1 together, suppose it represents string S, if this string S represents a number n, suppose it represents a number n, then let's write it as n. N it is created by taking the I minus 1 to I characters. If it is less equal to 26, we will do this. Okay. Now there is a case of 0. Okay. So there is one thing to understand, that suppose this is the case 3, 0, 2. So one thing you have understood, that if anywhere, if I get at digit d before 0 where d is greater than 2, there is no solution for this string, right? That I have told you. There is any character d before 0 which is greater than 2. Now if it happens, if the condition 2 happens, we will return 0. Now let's take where this condition 2 is not present. Okay, 1, 2, 2, 0, 1, 2. It's a very well string. Now here, think of this one. Think of this one. In a moment, I can extract either 1. Here is the answer, rest of the part. I can extract either 1 or I can extract 1, 2. But I cannot extract 0, 1, right? Because 0, 1 has a leading 0. Right? But we are solving the DP by taking the ith character and I minus yth character, I minus 1th character. So we are not bothering about this character while we are working with this I character. We are not bothering about the I plus 1 character. Okay, so we are not considering this 1, 2 case. So what we will consider? We will consider just the case where 1 is a separate case. I can extract from this string, many strings can be created by separating. So there may be 1 is a separate case, or 0, 1, or 1, 2, right? But as our DP process is working with I minus 1 and I, we not bother about this I plus 1. So this will not work. Also, if this is 0, 1, 0 is the leading 0 here, so it will not be applicable. So the only case is 1 is separated. Now for where the 1 is separated, the answer of this will be actually the answer up to this. Okay. let me do this by the example, small example. So for 1 it is 1, for 2 it is 2, that is 1 2 or 1 2. For these two it is 3, it is 1 2 2, 1 2 2 or 1 2 2, right? Now for 0, if I got a 0, I will check this character. So this is not making a number exceeding 26. So this will give me some answer. Okay. So not let's not think about this answer. Let's just I will just compute the answer. I will tell you how to do that. So here the answer will be 1 2 2 0, 12 2 0 and 1 2 2, that is 3. Yeah, 1 2 2 0 and 12 2 0 and 1 22 0. That is cannot be done. There is two cases. Answer will 2, right? I will tell you how to compute the answer where this character is 0. Now think of this 1. So how will it will compute answer for this? Where this is a separate case. If it is a separate case, I will just append this to the answer up to here. That is 1 2 2 0 1 and 12 2 0 1, right? So this actually does not contribute any extra answer. So I will place the answer for the 0. I am taking the case where there is a non-zero character after a 0. So in this case, I can only extract a string where the last string is 1, because I cannot extract the thing where last thing is 0 1, or I am not thinking about the last string as 1 2. Okay, that I will think in the case of 2, because in my DP process I am working with I and I plus 1th character, not I and I plus 1th character. What I want to say is that if I extract from this string where 1 is a separate case, and that means actually 1 is appended to the answer of this 0. It is up to here, the answer 1 will be appended to that. That is 1 2 21 and 12 21. The answer for here is 1 2 20 12 20. So after appending 1, it will be 1 2 21 12 21. The answer will be same, right? So the answer for this character will be same as this answer, that is 2. So that is the thing I wanted to say. So if there is a character here, then dpi will simply be dpi minus 1. So now for the case of 0, so for the case 1 2 2 0, we can either there are all possible ways. You can either extract 2 0 or 0, right? But extracting 0 separately is not allowed, so we have to extract 2 0 together, right? So if we extract 2 0 together, the answer will come from this, right? So see, 2 is actually the answer. So that is the thing. If you extract 2 0 together, extracting 2 0 together means appending 0 to the answers. Extracting 2 0 together is equivalent of extracting 2 separately and appending 0 to it. You extract 2 separately, so from 1 to 2 there are cases where 2 is separated, extracted separately. So in all these cases, just append 0. So that will be the answer for this, right? That will be the case where 0 is separated together, and this where 2 is separated uniquely. This thing comes separating 2 uniquely will come from the answer here. The answer for this 2 is made of two things. One is 2 is separated uniquely, which come from here, and the other is 22 is separated, right? So for 22 separation, the answer comes from here. So here the answer and here the answer. These two answers make the answer 3. The case where 2 is separated uniquely have the answer here, and that is equivalent to extracting 20 separately, because we are just appending the answer, we just appending 0 to the answers where 2 is extracted separately. So the cases where 2 is extracted separately is these two cases. In these two cases, just append 0. So this is actually equivalent to the answer where 2 is separated uniquely, which comes from this answer, right? So actually this answer here will depend on the answer here. Okay, so the answer here will depend on answer here, and if this digit is greater than 2, we will return 0, because there is no answer possible. So if this is the case where here is 0, here is somebody, d is less equal to 2, then dp of I is equal to dp of I minus 2. dp of I here, dp of I here will be equivalent to dp of I minus 2 here, right? This answer will come from this. So this is the thing, and now let's code keeping these points in mind. Okay, so the first thing is when there is leading 0. Second thing is this digit is greater than 2. Third thing is this thing where the cases are normal, we will just compute the result by this. When there is a x here, we will compute the result by this. When there is a d here, that is for the case of 0 anywhere, we will compute the result by this. Okay, this or this. Now let's code. You will understand by coding. Okay, so if it has a leading 0, we will return 0, and if string contains 0 0, or I copy this, this is for 2 0, it's for 4 0, 5 0, 6 0, 7 0, 8 0, 9 0. Also 2 0 is valid, right? So this is the case. In all these cases, we will just return 0. Okay, fine. And let's now create a DP. and our dp0 is 1. Start from and we'll calculate something. Character string s this string s is actually the I and I minus 1 character. Because to compute the value, right? So here suppose this is suppose the case 1 2 2 3 2. I am working for this. So to compute this value, I need this string. Then I will convert into integer. So that is the thing I am doing here. So there will be two cases. Either our character is 0 or the else part. Okay, so for this case 0 if 0 is here suppose, then I minus 2, this I minus 2 will not work here because this is I, this is our I minus 2 is here, which is nothing. So in this case what we are going to do is we are going to place dp I minus 1 plus 1, okay, because suppose the case is here for 1 or 2 will store this 1 0 2 1 2 1 0 2 1 2, right? So what we are going to store here? 1. For 0 what we are going to store? So 1 0 can be separated as 1 0 or 1 0. So their answer should be 2. It is 1 plus 1 2. You can answer directly store here 2. The answer will be 2. What if, right? So let's do that. So if at the place of dpi is I equal to 1, if I equal to 1, we are going to store what? We are going to store 2. Either we are going to store dp I minus 2. Okay, so for the case I is not 0, here suppose I is not 0, we have to, there may be two cases. Either the previous character I minus 1 is 0 or not. If this is 0, this character is 0, then this is the solution, okay, right? Here is my x, ith character. If the previous character is 0, this is my solution, right? So if str.char at I minus 1 is equal to 0, dpi minus 1. Else, now this is not 0. So this case may be possible, or this case may be possible. This case is gone. 0 case we have done it. Now the previous character together with the previous character, this number may be less equal to 26, or it may be greater than 26, right? There may be two cases. So let's take two cases. If val, that is what this number we already computed here, is greater than 26, we are going to do something. Else we are going to do something. If value the value is greater than 26, uh, yeah, if the value is greater than 26, that is here, then I cannot extract this at a whole, right? So did I done this? No, I have not done this case here. So what happens actually, this is a normal case, nothing to worry. So see, so for the answer of, this is my I, this is my I minus 1 3. So 3 2 cannot be separately extracted, that is in the all possible answers 3 2 cannot be uniquely separated. You can uniquely separate only 2. Okay, there may be many answers. Now in every answer 32 cannot be the last one, that is last one to be separated, because 32 is greater than 26 and we do not have any number, we cannot allow any number to be greater than 26. So 2 can be separated. Now the case of 2 which is separated, so how we computed till now the case of 2 uniquely separated, it is the answer for the case of the answer for 3, right? That is the case, right? So in the all the answers of 3, if I in the all the answers of 3, if I just append 2, this will be the case where 2 is uniquely separated. So this answer, the answer where 2 is uniquely separated is equivalent to the answer for 3, is equivalent to the answer for 3 here. Okay, because 32 is greater than 26, so we cannot do this part as a whole. Okay, so answer will be this. So there is another case I forgot to mention. So if everything is normal, here is x, here is y, but xy is greater than 26, then our dpi will be just dpi minus 1, right? Okay, so it will be now the case where value is less equal to 20, less equal to 26. Okay, so this is a normal case. Okay, so this result will be here. This is the normal case. The result is here. This I minus 1 to I number will less equal to 26. The answer will be dpi equal to dpi minus 1 plus dpi minus 2. Right? That is what I am writing here. Will be dp I minus 1 plus dp I minus 2. Now as we have to return the modulus of this, so we will return dp of dp dot length minus 1 and we will give everywhere a mod. Okay, 1 2 3 4 5 6 7 8. We have to return the result modulo 10 to the power 9 plus 7. Okay, that's what we are doing it. So give everywhere a mod sign. Why we have to keep that here? And here. Okay. I think everything is okay. then let's quit this and let's submit this. I think everything is okay. Okay, there is some okay, so here we will be passing S. Line 47. Okay, so it will start from 1. $59 DP mod. Okay, so here also I can be as I can be 1 here, so 1 minus 2 is a invalid thing, right? This is the head where everything is normal. So if I equal to 1, what we gonna return is let's take a case where everything is normal. This is the case 1 2 3. So here at I equal to 1, the answer is what? The answer before it, right? The answer before it, right? The answer before it plus the answer at 2. So this can be 1 2 or 1 2. But if it was like 4 2 3, it will be 4 2 only, not 42, right? So if I equal to 1, the answer will be dp. So value is here. The value here is less equal to the thing. So it will be dpi minus 1 plus 1. I think dpi minus 1 plus 1. It will be dpi minus 1 plus dpi minus 1 plus 1. I think you understood. This is my ith element. The answer for it will be the answer for here plus 1, y plus 1, because this is the 1th element. Okay, you have to remember that the answer will here will be like 1 only. So either you can separate this by uniquely, either you can separate 2 as uniquely, that will be 1 2 separately, or either you can keep this ith element together with the first element, so that will give you 1 2. So these two answers you will get always. Okay, but if there is a case like this 4 2 3, then you will have only one guess, but that case is not this, because this 4 2 will become in this case, that is value is greater than 26, and that we have done already. So you can do that. You can just write here 2. Okay, because there will be definitely just 2 cases for this, because for dp 0 it is 1, right? So dp I minus 1 plus 1 is actually 1 plus 1, and this is 2, which is correct. Let's compile this. Okay, so it's working. Let's submit this and see. Okay, So we done this. So I hope you like the video, and if you do, then please like, share and subscribe. See you in the next video.